Hi, hello all, welcome to Jab, and this is another video in the programming series of Learner's Launch. In the previous videos, we saw the first part of the process of programming. This is the continuation of that process. So let's start our topic without any further ado. There are three basic terms or flow of logic that is technically known as control structures. They are known as such because as these are the structures that control the execution of a program. We must know before entering into programming world, there are three things you must know. Firstly, sequencing. Second, branching. And third, iteration. We will try to explain all the three one by one. Firstly, sequencing. In this structure, the flow is one by one. Consider a calculation concept where we use the BODMAS rule, for instance. We do in a sequence like first consider the brackets and then do the division and then the multiplication, then addition and finally subtraction. This control structure works in the same way as one by one. Secondly, we'll talk about branching. Consider a situation where we do a decision making like yes or no or some condition based on which the path has to be decided. In this control structure, we have two types or ways of branching like two-way branching and multi-way branching. In two-way branching, the condition check is a simple yes or no answer kind of questions. So this is called as two-way branching. Consider an example where the question is to check whether A is greater than B. Then we use two-way branching. The multi-way branching is based on a value to decide the flow. For instance, consider an outcome from a dice. It is anything between 1 to 6. So based on which the flow or the further process is to be carried out. And finally, iteration. The last fundamental technique is iteration, or in simple terms, repetition of a set of instructions. Repeating an action 2 or 3 times can be easy, but consider a situation of going beyond 100 or say 1000, but the same action we write 5 lines for each time and the code becomes huge and unreadable format. So at times, whenever we need repetition, this iteration would be used. Consider a situation where we need to find the total of 5 subject marks scored by 50 students. First, we need to write a logic to add all the subject marks for one student, and then we can repeat this for the 2 students, but that too is tedious. So it's better to iterate the action, and for iteration we require an index variable or control variable. Variable is nothing but a value that keeps on relying or varying. We will be discussing about these when we start our programming. This control variable initially has to be given the initial value to start and check if this index is less than the final value of items. We need to perform the set of actions, then increment the count of index variable by 1 as we have done with our action for the first time. Then give the control again to the conditional check where we see whether we meet the final value and repeat this until we reach the final value. These are the major fundamental control structures we need to be aware before starting our coding. After we are done with the flowchart or pseudocode, what next is to do a check of the working of our solution, and is our solution in compliance of an all algorithm standard. That is, a solution has finite number of steps. A solution can be executed without any ambiguity or confusion. Each step is executed within less space and less time as much as possible. The entire program should be done in finite amount of time. A method of checking the way in which a computer will work using our flowchart and pseudocode is called as walkthrough. Assume the flowchart we explained in the last video where we did sum of 2 numbers. In that, set the values as per your choice and check whether the flow can start from the start and end in the end block as per the following the flow in the sequence. That's in the section. We will see the continuation of the process of creating a program in the next video. Meet you all in the next video. Bye. Hope all is well.